Hi there, welcome to this video where we continue taking a look at Bertrand Russell's Principles of Mathematics. This video follows on from the last video that I made where I started to take a look at chapter 3 from Principles of Mathematics, which is titled Implication and Formal Implication. And in that video, I got up to the end of section 40. So in this video, quite naturally, we're going to be kicking off with section 41. And all being well, we're going to go through to the end of this particular chapter. So at that point, I'm going to leave it in your hands, really, what I do further with this Principles of Mathematics. If you would like me to continue with making more videos on Principles of Mathematics, let me know. If there's particular sections of Principles of Mathematics that you would like me to concentrate on, let me know. If you've had enough of Principles of Mathematics and you'd like me to move on to something else, let me know. I have to confess that once I'm done with this video, it's probably going to be a while before I do get around to making any more videos on Principles of Mathematics, because I've got some other things that I'm looking at that I really want to make some videos on, and just other things besides. Principles of Mathematics it's quite time consuming to go through, and I can't necessarily dedicate several months to just doing Principles of Mathematics. But if it is something that you find interesting and useful and you want me to continue, then please let me know. So before we get started, I'd be really grateful if you would consider, if you haven't already done so, subscribing to the channel, hitting the like button, and of course leaving a nice positive comment in the comments section. That would be great. So this video is going to work in a very similar way to my previous videos that I've recently uploaded, in that it's going to be unscripted. So I don't know exactly what I'm going to be saying until I've actually said it. I'm going to be reading through the sections basically line by line and stopping every now and again to make various comments and explanations wherever I think it's relevant and appropriate to do so. There are several paragraphs where there's not really much for me to say in the sections coming up. So if it does seem that I'm just kind of reading the page, just reading the words of the page and not really saying anything, that's probably because I am. But the reason I'm going through things in the way that I am with Principles of Mathematics is because it's so difficult really to condense it down. So for what it's worth, I may as well just actually read out in its entirety. Okay, so also I have made some, even though this is chapter 3, I've already made videos on chapters 4, 5 and 6, and because of the way that Principles of Mathematics kind of reads, it may be that I do end up referring to some of the things that that are discussed in those chapters. When you read Principles of Mathematics, you mustn't expect for everything you mustn't expect it to work in a purely cumulative way, and always kind of going in the forwards direction. That you read this, and what comes later only ever depends on what you've read previously. So sometimes something that you're reading now might not be fully explained until much later in the book. And once you've read that much later in the book, it might be worth actually coming back to the earlier points, rereading those, and you might find that you better understand them, and that also you better understand the stuff later in the book as well. So it's kind of backwards and forwards. It's not nice and in a nice straight line, nice linear single direction through the book. So it's quite natural, in my opinion, to refer to even later chapters in the book. So here I'm working through chapter 3. If I do need to, and I might not need to, but if I do need to, it would be perfectly reasonable, in my opinion, to refer to, I don't know, sections in chapter 8 or chapter 10 or something like that. I might not need to. Like I say, I don't know what I'm going to be saying until I've actually said it. So let's get going. So I'll keep up on the screen roughly the part of the chapter that I'm going through at a given time, but as always, I do have a tendency to forget to change the screen every now and again. So if you do have your own version, your own copy of Principles of Mathematics to hand, that would be probably better for you to keep track of where I am. So we're up to here, section 41. So let's get started then. So section 41. So it may be doubted to begin with whether X is a man implies X is a mortal is to be regarded as asserted strictly of all possible terms, or only of such terms as are men. So Russell's going to make a bit of a big deal about this. So we've got this. Let me get my writing pad sorted. X is a man implies X is a mortal. Okay, so we're dealing with what are called formal implications here, and Russell's got some very strict views about formal implications. So formal implication, as we'll see, in fact, I'll read it out now. It's in section 42, so I'm getting a bit ahead of myself, and I will be coming back to this later in the video. But right at the beginning of section 42, Russell says the following. It's to be observed that X is a man implies X is a mortal is not a relation of two propositional functions, but is itself a single propositional function having the elegant property of being always true. Okay, so it's a single this X is a man implies X is a mortal is a single propositional function which has the elegant property of being always true. Now, we've got a variable here with a propositional function. We've got a variable involved. In fact, we've got two occurrences of it, two instances of our variable X. So they correspond. If we replace one of these variables with a particular fixed term, we need to replace the other one as well with the same fixed term. But for this to be a formal implication, we have to have that X has a totally unrestricted range. So we can replace X with any term. Okay, an elephant, a coffee cup, a tree, whatever. Okay, Socrates is a common one that he's going to be using, right? But there's no restriction, according to Russell. If we want this to be a formal implication, we want to consider it as a formal implication, then X has to have a completely unrestricted range. Okay, so what he's going to be taking issue with here is effectively what Peano, Giuseppe Peano, who effectively places a restriction on the range of values of X. And in Russell's view, this effectively this has the effect of removing the formal implication, making X is a man implies X is a mortal something that is not really a formal implication. In fact, it's not even an implication at all. So Peano is a lot of Russell's ideas, and particularly his symbolism that he uses in, say, Principia Mathematica, are derived from Peano's ideas and Peano's symbolism. So there's a lot of influence of Peano as you read through Principles of Mathematics. Another thing that I might say is that for those of you that are familiar with Principia Mathematica, there is a notion of formal implication in Principia Mathematica, and by that time Russell had to change his views regarding this unrestricted nature of variables, because in Principia Mathematica variables are restricted necessarily. They're restricted to a single type. A variable in Principia Mathematica can only range over one particular type. There are occasions in Principia Mathematica where it appears that we've got a variable that kind of spans across different types, but it's not really the case. It's not strictly speaking the case. So a variable in Principia Mathematica has it's restricted to a type, but within a particular type, the variable is unrestricted. So we still have formal implications in Principia Mathematica, but the formal implication, the variable, it's an apparent variable, will range over, will have unrestricted range still, but will be restricted to it, so it'll have unrestricted range within a particular type. Okay, so there is a difference between the what Russell's talking about, formal implication in Principles of Mathematics, and formal implications understood in Principia Mathematica, just in case there's anybody that's not aware of the distinction. Okay, so coming back to what Russell says then, Peano, though he is not explicit, appears to hold the latter view. So in other words, so going back to what he said, when he says that it may be doubted to begin with whether X is a man implies X is immortal is to be regarded as asserted strictly of all possible terms, or the latter view that he's talking about, only of such terms as are men. Okay, so Peano appears to hold the latter view, that X ranges, this X is a man implies X is immortal is to be asserted only of such terms as are men. But in this case, the hypothesis ceases to be significant and becomes a mere definition of X. X is to mean any man. The hypothesis then becomes a mere assertion concerning the meaning of the symbol X, and the whole of what is asserted concerning the matter dealt with by our symbol is put into the conclusion. The premise says X is to mean any man. The conclusion says X is mortal. But the implication is merely concerning the symbolism. Since any man is mortal, if X denotes any man, X is mortal. Thus, formal implication on this view has wholly disappeared, leaving us with the proposition any man is mortal, as expressing the whole of what is relevant in the proposition with a variable. It would now only remain to examine the proposition any man is mortal, and if possible to explain this proposition without reintroducing the variable and formal implication. So, by making this restriction to the variable, we've lost the implication. Not only is it not a formal implication anymore, it's just not even an implication anymore. And Russell really wants to, there is a great emphasis on the notion of formal implication in Russell. He sees it as a fundamental aspect of mathematical reasoning. So he's quite keen to ensure that formal implication is something that is retained. So it must be confessed that some grave difficulties are avoided by this view. So there's an example coming up that I'm going to spend a little bit of time discussing. Consider, for example, the simultaneous assertion of all the propositions of some class K. This is not expressed by X is a K implies X for all values of X. Okay, so I'll write that out. So X is a K implies X for all values of X. So we would like this to be a formal implication. Okay, we'd like this implication here to be a formal implication, but there are some problems with this that mean that this is not going to be a formal implication as it is. So the problem that we've got is that remember what was said at the beginning of section 42, that basically a formal implication, X is a man implies X is immortal, is a single propositional function having the elegant property of being always true with an unrestricted range for the variable X. Okay, well, if we allow X here to have a completely unrestricted range, then what we find is that X is a K implies X will be false for, well, at least any terms, any values of X which are not propositions. Why is that? Well, this goes back to arguably what Russell says in, where is it? I think it's section 16. So chapter 2 in section 16. So I won't bring this up on the screen. I think I talked about this in the previous video, but it's important enough for me to kind of repeat here. Propositions are defined by Russell in a very particular way, as we'll see. So this is from section 16. So it may be observed that although implication is indefinable, proposition can be defined. Every proposition implies itself, and whatever is not a proposition implies nothing. Hence, to say P is a proposition is equivalent to saying P implies P. He also says later in section 41, only propositions can be implied. So I'll be coming to that section in a while, but just to kind of jump ahead a little bit again, only propositions can be implied. So if I replace X with, I don't know, what did I say earlier? A coffee cup, right? So a coffee cup is a K, which is false, implies a coffee cup, or this coffee cup, whatever, right? So X is a K implies X. In that case, if X is this coffee cup, do I have a coffee cup? I do. If X is this coffee cup, then that implication will be false. Even though X is a K is a proposition, right? So this is a proposition. That's not a problem. It's a false proposition because this coffee cup is not it's not a proposition in this class of propositions, K, but because this X here is not a proposition, the implication must be false, right? Only propositions can be implied. So therefore, this propositional function, X is a K implies X, will be false for very many values of X. So this in no way is going to be a formal implication. So we've either got to accept, as it is here, that this X is a K implies X for all values of X is not going to be a formal implication, or we restrict the range of the variable X to propositions. Not necessarily propositions in the class K, but just propositions. But then this is a further restriction that we're applying to the variable, which means that the implication is still not going to be a formal implication. So one way or the other, whichever route we take, we can't win. We can't make this into a formal implication. Well, we can do, actually. There is something that we can do that's going to be, because going back to what Russell says in section 16, that a proposition can be defined effectively as something like P implies P. Okay? A proposition implies itself and only propositions can be implied. Then this will only be true, this implication will only be true in the case when P is a proposition. If P is not a proposition, remember P here is a variable just as much as X is. Okay, we've written P, it might be suggesting that we're intending P to be understood as a proposition. And that might be what we've kind of got in mind, but P is still, for all intents and purposes here, a variable, and we can allow P to range over any terms that we want. And this is really important to Russell, that we allow variables to range without restriction. So even when we've got something where it seems to clearly be the case that we need the variable to be a proposition, we can't just assume that the variable will only take values that are propositions. So this P implies P will be true only in the case when P is a proposition, and when P is not a proposition, it will be a false implication. So what we can do, and what we'll see Russell does, is he kind of inserts an extra little implication into this X is a K implies X. Into the antecedent, he'll insert this X implies X. And this will kind of fit, not into the antecedent. Well, we'll see what he does anyway. But he inserts this And this has the effect of effectively restricting the variable without actually restricting the variable. So this is fine. The variable will still have a completely unrestricted range. But by inserting this extra little bit, this x implies x in a particular way, what he guarantees is that this x is a k implies x is a propositional function. Well, along with the x implies x, it's a propositional function which will have this elegant property of being always true, and hence will be a formal implication. Okay, so going back to what he says then. So consider, for example, the simultaneous assertion of all the propositions of some class K. This is not expressed by x as a k implies x for all values of x, for as it stands, this proposition does not express what is meant, since if x be not a proposition, x is a k, which is a proposition, cannot imply x, which is not a proposition. Well, not necessarily a proposition. Hence, the range of variability of x must be confined to propositions, unless we prefix, as above in section 39, the hypothesis x implies x. This remark applies generally throughout the propositional calculus to all cases where the conclusion is represented by a single letter. Unless the letter does actually represent a proposition, the implication asserted will be false, since only propositions can be implied. So the problem really is it's partly a problem with the way that we kind of symbolically represent things, I guess. If we use a single letter. So, okay, again, jumping ahead a little bit. If we've got P implies Q, implies P implies Q, then in this case, we don't actually require P and Q to be propositions. Okay? Because if P or Q, if either P or Q is not a proposition, then these implications will simply be false, but they will still be propositions. That's the thing. They're still propositions, but they're just false propositions, false implications. But if this, particularly if this implication is false, P implies Q is false, then it doesn't matter whether this implication, well, I mean, this implication will be false also because they're the same proposition. But this implication in the middle here, which is, I guess, the primary implication, and these other two are kind of secondary implications, the primary implication will still be true. Because, so, the distinction here between what we've got with P implies Q implies P implies Q and X implies X is that the things that are either side of the principal or primary implication are represented in different ways. So here we've got that they're represented by single letters, whereas here they're not. Right? We've got P implies Q. This which is not represented by a single letter. Okay, so this is kind of one of the distinctions that he's making here. So the point is that if x be our variable, x itself is a proposition for all values of x, which are propositions, but not for other values. This makes it plain what the limitations are to which our variable is subject. It must vary only within the range of values for which the two sides of the principal implication are propositions. In other words, the two sides, when the variable is not replaced by a constant, must be genuine propositional functions. So a propositional function is a function whose values are propositions. So, okay, x, just the variable x is not a propositional function. okay? Because the values of X may or may not be propositions or whatever, right? P implies Q is a genuine propositional function. Irrespective of what the values of P and Q are, we always end up with a proposition. It might not be a true proposition, a true implication, but it's still a proposition. So P implies Q, if we look at P and Q as variables, is a genuine propositional function. If this restriction is not observed, fallacies quickly begin to appear. It should be noticed that there may be any number of subordinate implications which do not require that their terms should be propositions. It is only of the principal implication that this is required. Take, for example, the first principle of inference. If P implies Q, then P implies Q. So this is the example that I've just been kind of looking at. This holds equally whether P and Q be propositions or not, for if either is not a proposition, P implies Q becomes false, but does not cease to be a proposition. In fact, in virtue of the definition of a proposition, our principle states that P implies Q is a propositional function, i.e., that it is a proposition for all values of P and Q. But if we apply the principle of importation to this proposition so as to obtain P implies Q together with P implies Q. P implies Q together with P implies Q. We have a formula which is only true when P and Q are propositions. So this is, if we go back to chapter 2, where is it? So the propositional calculus in section 18, is it? So in section 18, the principle of importation is... I think it's number 7 or number 8? It's number 7, I think, the principle of importation. So that's in section 18 from chapter 2. So P implies Q implies P implies Q. If we use importation, what we get is that P implies Q. No, sorry, just a single comma. P implies Q, and what is it? Together with P, and P implies Q. Okay, so if, let's say for the time being that P and Q are restricted to propositions, then this is a valid symbolic transformation that we can make. P implies Q implies P implies Q implies P implies Q and P implies Q. Okay, I'm sure that if you look through Principia Mathematica, something similar to this will be in there somewhere. Maybe, I can't remember. But the problem that we've got is, whereas in the first case, P implies Q implies P implies Q, this does not depend on whether P and Q are propositions or not. The implication will still hold. In the second case, we certainly need Q, P and Q to be propositions here, right? Because again, if Q is not a proposition, then it can't be implied, right? It can't be implied. And if P is not a proposition, then it kind of causes problems as well. So in this second case, for P implies Q implies P implies Q to be equivalent to, I don't know if it's equivalent to or whatever, to P implies Q and P implies Q, we actually need an extra couple of conditions in there, which is that P and Q are propositions, in which case we need to insert P implies Q and P implies P and Q implies Q. So we kind of need to insert that in here to make it valid. Okay, we need so we need to ensure that for this, it's kind of a formal implication that we're trying to make between P implies Q implies P implies Q implies P implies Q and P implies Q. That would not be a formal implication. Because P implies Q implies P implies Q is always true, whereas the latter could be false in the particular case where Q is not a proposition. So therefore, this implies here will not represent a formal implication. Whereas if we insert these extra conditions, P implies P and Q implies Q, that will effectively restrict P and Q to propositions. I don't think I'm explaining this very well, but let's go on. Where are we? If we apply the principle of importation to this proposition so as to obtain P implies Q together with P implies Q, we have a formula which is only true when P and Q are propositions. In order to make it true universally, we must preface it by the hypothesis P implies P and Q implies Q. In this way, in many cases, if not in all, the restriction on the variability of the variable can be removed. Thus, in the assertion of the logical products of a class of propositions, the formula if X implies X, then X as a K implies X appears unobjectionable and allows X to vary without restriction. Here the subordinate implications in the premise and the conclusion are material. Only the principal implication is formal. So material implications are between effectively particular propositions. But what we'll see as a formal implication is the simultaneous assertion of, it's viewed by Russell as the simultaneous assertion of a class of material implications. But there are some more details that he needs to iron out in the next few sections. So returning now to X is a man implies X is a mortal, it is plain that let's change that. Right. Returning now to X is a man implies X is a mortal, it is plain that no restriction is required in order to ensure our having a genuine proposition. And it is plain that although we might restrict the values of X to men, and although this seems to be done in the proposition all men are mortal, yet there is no reason, so far as the truth of our proposition is concerned, why we should so restrict our X. So, in other words, if we don't need to restrict a variable, we shouldn't. And if there's no reason, just like in this latter case where we inserted this P implies P and Q implies Q, we insert an effective restriction without imposing an actual restriction. If we don't need to do that, we don't do that. So if we've got X is a man implies X is a mortal, if we don't need to insert some kind of restriction that restricts X to a particular category of terms, then we don't. So whether X be a man or not, X is a man is always, when a constant is substituted for X, a proposition implying for that value of X, the proposition X is immortal. And unless we admit the hypothesis, equally in the cases where it is false, we shall find it impossible to deal satisfactorily with the null class or with null propositional functions. We must therefore, so I think he's saying there that we can't have a prejudice really against false propositions. We actually need false propositions. As we saw in one of the previous videos that I made when we looked at classes and the issues surrounding the null class, for example. We need propositional functions that are true for that are false, let's say. False for all values X. Okay, we need these propositional functions so that we can talk about the null class. Okay. So we might have something like the x is a square circle. It's a very common example. X is a square circle. We need propositional functions like this, and we need to. We can't restrict that to just those values of x that are true, because it's not true for any values of x. So we can't have, if we insist on restricting our variable to those values of x which make a propositional function true, then we can't have a null class on it in any sort of way. I mean, admittedly, Russell does say in chapter 6 that from an extensional point of view there isn't a null class anyway, but he does have a way of talking about what is effectively in the null class by introducing null class concepts. Okay. So where was I? We must therefore allow our x, wherever the truth of our formal implication is thereby unimpaired, to take all values without exception. And where any restriction on variability is required, the implication is not to be regarded as formal until the said restriction has been removed by being prefixed as hypothesis. Okay, so again, Russell is insistent on this view that a formal implication has to, the variables in the propositional function that is what we're hoping to be a formal implication, it has to have a totally unrestricted range. So then he says, if psi of x be a proposition whenever x satisfies phi x, where phi x is a propositional function, and if psi x, whenever it is a proposition, it implies chi x, then psi x implies chi x is not a formal implication, because we've got all sorts that. So psi x implies chi x is not a formal implication because of all these various restrictions that have been placed on it. Okay, but phi x implies that psi x implies chi x, and this would read it. This would effectively group these together. So implies that suggests to me that there's some brackets that belong around this that can be effectively imagined around this. Psi x implies chi x. This is a formal implication because there's no restriction placed on this. Okay, so 42. It's quite a long section, that 41. It is to be observed that x is a man implies x is a mortal is not a relation of two propositional functions, but it is itself a single propositional function having the elegant property of being always true. So compare this with material implication, right? So if we've got P implies Q, and going back to something that he says in section 37. So he talks about material implication as effectively being a relation which holds between certain propositions. But now when it comes to formal implications, so we've got x is a man implies x is a mortal. This implication here is not a relation between this propositional function and this propositional function. So this is quite a distinction, right? This implication, which is a material implication, is a relation between this fixed proposition and this fixed proposition Q. But this implication, which is a formal implication, is not a relation, in Russell's view, between this propositional function x is a man and this propositional function x is a mortal. So It is itself a single propositional function having the elegant property of being always true. For X is a man is, as it stands, not a proposition at all, and does not imply anything. So X is a man is not, it's a propositional function. The values of a propositional function are propositions, but the propositional function itself is not a proposition. We might loosely and kind of carelessly speak of it as a proposition sometimes. Maybe if we've got in mind that it does, that we have kind of picked out one of the fixed values of the propositional function. But a propositional function is, strictly speaking, not a proposition. So it can't imply anything, and it can't be implied by anything. And that's why he suggests that this implies, this formal implication here is not a relation. It's not a relation of implication between X is a man and X is a mortal. Because it can't be. We must not first vary our X in X is a man and then independently vary it in X is a mortal. For this would lead to the proposition that everything is a man implies everything is a mortal, which, though true, is not what was meant. This proposition would have to be expressed in the language of variables, if the language of variables were retained by two variables, as X is a man implies Y is a mortal. So, in other words, if we do treat this formal implication as a relation between two propositional functions, the variables, these two X's here, would be kind of independent. And it would be really more correct in that case to say X is a man implies Y is a mortal, so that we understand that they're independent variables. But this is not at all what is being what is meant. We do need these two variables to be referring to the same term, effectively. So Russell's going to spend the next couple of pages talking about how to overcome this little issue. But this formula too is unsatisfactory for its natural meaning. So he's talking about X is a man implies Y is a mortal. This formula too is unsatisfactory for its natural meaning would be, if anything is a man, then everything is a mortal. The point to be emphasized is, of course, that our X, though variable, must be the same on both sides of the implication. And this requires that we should not obtain our formal implication by first varying, say, Socrates in Socrates as a man, and then in Socrates as a mortal, but that we should start from the whole proposition, Socrates as a man implies Socrates as a mortal, and vary Socrates in this proposition as a whole. Thus our formal implication asserts a class of implications, not a single implication at all. We do not, in a word, have one implication containing a variable, but rather a variable implication. So, in other words, so I'm going to go on to the next page, actually, so it's coming up anyway. So, when we've got X is a man implies X is a mortal, then effectively what we have corresponding to this is a class of implication, a class of material implications. A is a man implies A is a mortal. B is a man implies B is a mortal. C is a man implies C is a mortal, and so on and so on and so on. Okay, for every term, right? A, B, C. So X ranges again over all terms. We've got this class of implications, and they're all being asserted. And it's this that corresponds to our formal implication. So it's not that we it's not really that we're varying the X so much as we're choosing a particular material implication from this class. Now, when he says that our formal implication asserts a class of implications, I'm not entirely sure how to interpret that, whether he means that we assert each of the material implications separately and individually, or if we assert them as kind of some kind of logical, potentially infinite logical product. I'm not really sure. I'm not sure if it really matters too much, but it's worth bearing in mind that there is, when it comes to Principia Mathematica, there is a distinction between asserting a propositional function, so saying something like phi x, for instance, and asserting for all x phi x. So this would be, this first one, asserting a propositional function, is what you're saying is that each individual value of the propositional function can be asserted. Okay, so phi a can be asserted, phi b can be asserted, phi c can be asserted. But in the latter case, this for all x phi x, this is a simultaneous. This is almost like, it's not quite right to think. In fact, it's not right at all necessarily to think about it like this. But this is like a logical product, in my view, and there is a distinction made between these two ideas, certainly in Principia Mathematica. I'm not sure in Principles of Mathematics whether that distinction is still as if it's as pronounced. I think that there does seem to be a distinction there, but I don't think Russell has arrived at the point yet where he's fully disengaged these from each other, if that's the right word to use. Where was I up to? Right, so we have a class of implications, no one of which contains a variable, and we assert that every member of this class is true. So again, we're asserting every member? Are we asserting them individually? Because he uses the word every. Thinking back to denoting, the video that I did on denoting on chapter 5, every, he calls, he associates this with a propositional conjunction. So I'm not sure whether he means we're asserting each implication of this class separately and individually, or as a conjunction. This is the first step towards the analysis of the mathematical notion of the variable. But it may be asked, how comes it that Socrates may be varied in the proposition Socrates is a man implies Socrates is mortal? In virtue of the fact that true propositions are implied by all others, we have Socrates is a man implies Socrates is a philosopher. So section 44 coming up is where Russell's gonna give an explanation, his provisional explanation to this. But in this proposition, alas, the variability of Socrates is sadly restricted. Because, okay, Socrates is a man implies Socrates is a philosopher is maybe a true proposition. But if we replace Socrates by another term, unlike in the case where we've got Socrates as a man implies Socrates is immortal, this is always true. In Socrates is a man implies Socrates is a philosopher, we might write, for example, I might use myself, John is a man implies John is a philosopher. This would be false, because yes, I'm a man, but I'm not a philosopher. So why is it that in Socrates is a man implies Socrates is mortal? We can vary, we can change Socrates to any term that we want, and it will be true. The implication will be true. Whereas in Socrates is a man implies Socrates is a philosopher, this is not always true. Even though there's very many formal similarities between Socrates as a man implies Socrates is mortal, and Socrates as a man implies Socrates is a philosopher. There's a lot of formal similarities between them, but why is it that one of them, Socrates as a man implies Socrates is mortal, is always true, but the other one is only sometimes true? In the case where we've got a man, a term that is a man. In fact, no, it would be true. It wouldn't have to be a man, but if we replace the Socrates with another term that is a man, then that man will also have to be a philosopher. And if we replace with a term that is a man but is not a philosopher, then we get a false proposition. I mean, we could still replace Socrates with any other term. This bookmark, for example. We could replace Socrates with this bookmark is a man, which is clearly false, implies this bookmark is a philosopher. But because the antecedent is false there, the implication is still true. So how can we explain this? This seems to show that formal implication involves something over and above the relation of implication, and that some additional relation must hold where a term can be varied. In the case in question, it's natural to say that what is involved in the relation of inclusion what is involved is the relation of inclusion between the classes men and mortals. So in other words, we've got classes, the class of men and the class of mortals, and there's a certain relation between these two classes. One is entirely included in the other. Okay. Whereas if we take the class of men and the class of philosophers, there isn't. So which way will it be? The class of men is not entirely contained in the class of. In the class of philosophers. So the very relation which was to be defined and explained by our formal implication, but this view is too simple to meet all cases, and is therefore not required in any case. A larger number of cases, though still not all cases, can be dealt with by the notion of what I shall call assertions. This notion must now be briefly explained, leaving its critical discussion to Chapter 7. So Chapter 7 is on propositional functions. So, Section 43. It's always been customary to divide propositions into subject and predicate, but this division has the defect of omitting the verb. It's true that a graceful concession is sometimes made by loose talk about the copula, but the verb deserves far more respect than is thus paid to it. We may say, broadly, that every proposition may be divided, some in only one way, some in several ways, into a term, the subject, and something which is said about the subject, which something I call the assertion. Thus, Socrates as a man may be divided into Socrates and is a man. Okay, so let's clear a bit of space here. So Socrates is a man. So Socrates is the subject, and is a man is the assertion. So this is what an assertion that is made about the subject, something that is said about the subject. So the assertion is not a proposition, it's not true or false. So thus Socrates as a man may be divided into Socrates and is a man. The verb, which is the distinguishing mark of propositions, remains with the assertion. So I've done chapter 4, he talks more about verbs and the different forms of verbs that can appear in different situations and things like that. So I'm not going to go over that here. The assertion itself, being robbed of its subject, is neither true nor false. In logical discussions, the notion of assertion often occurs, but as the word proposition is used for it, it does not obtain separate consideration. Consider, for example, the best statements of the identity of indiscernibles. If x and y be any two diverse entities, some assertion holds of X which does not hold of Y. But for the word assertion, which would ordinarily be replaced by proposition, this statement is one which would commonly pass unchallenged. Again, it might be said, Socrates was a philosopher, and the same is true of Plato. Such statements require the analysis of a proposition into an assertion and a subject, in order that there may be something identical which can be said to be affirmed of two subjects. So, section 44. We can now see how, where the analysis into subjects and assertion is legitimate, to distinguish implications in which there is a term which can be varied from others in which this is not the case. Two ways of making the distinction may be suggested, and we shall have to decide between them. It may be said that there is a relation between the two assertions, is a man and is a mortal, in virtue of which, when the one holds, so does the other. Or again, we may analyse the whole proposition, Socrates as a man implies Socrates as a mortal, into Socrates and an assertion about him, and say that the assertion in question holds of all terms. Neither of these theories, Russell's not happy with either of these theories, actually, these suggestions, but he does choose one of them as more likely to be true than the other one, as we'll see. So neither of these theories replaces the above analysis of X as a man implies X is a mortal into a class of material implications, but whichever of the two is true, if either, carries the analysis one step further. The first theory suffers from the difficulty that it is essential to the relation of assertions involved that both assertions should be made of the same subject. Okay, so the problem that we've got when we just talk about the assertions, so we've got is a man implies is a mortal, where these dots are representing whether the variable is going to go, but an assertion makes no reference to to the subject. The assertion is it's just the assertion. We're dealing with the bare assertions here, without reference to any subject. So there's no way here, without some kind of additional assumption of ensuring that what the term that we place here in this space is the same as the term here. Now, obviously, we can say to somebody, "Oh, here's kind of some kind of relation of these two assertions. Is a man implies is a mortal. There's two spaces here. You can only fill these spaces with the same term." But this is kind of an extra logical thing that's been brought in, another principle that's been brought in. That might not be justifiable from a logical perspective, and all of this has to be looked at through from a logical perspective. Yes, it's obvious that we can say this to somebody. We can say there's these two spaces here; they have to be filled by the same term. But that's entirely different from having a purely logical viewpoint on purely logical perspective on things. The second theory appears objectionable on the ground that the suggested analysis of Socrates as a man implies Socrates as a mortal seems scarcely possible. How are we going to what we're going to take as the assertion here in X as a man implies X is a mortal? It seems kind of difficult to analyze this into a subject and an assertion, is what he seems to be saying here. The proposition in question consists of two terms and a relation. The terms being Socrates is a man and Socrates is a mortal. And it would seem that when a relational proposition is analysed into a subject and an assertion, the subject must be one of the terms of the relation which is asserted. This objection seems graver than that against the former view. I shall therefore, at any rate for the present, adopt the former view and regard formal implication as derived from a relation between assertions. Okay, so in other words, we're taking the view, or Russell's taking the view, that there is a relation between the two assertions, X is a man and the two assertions is a man and is immortal, in virtue of which when the one holds, so does the other. And this relation therefore will not hold between the assertions is a man and is a philosopher. And this is one way that we can view this. When he says earlier that there seems to be something when it comes to formal implication, some relation over and above that of implication, and he's suggesting that this could be it, right? That there is some relation between the assertions that holds in some cases when we legitimately have a formal implication, and doesn't hold in other cases. So there's this particular relation which holds between the assertion is a man and the assertion is immortal, and therefore we can form this formal implication. It doesn't mean that, and relations have sense as well, so it's a relation between is a man on one side and is immortal on the other, and they can't necessarily be flipped round. But this relation evidently does not exist between the assertions is a man and is a philosopher. Okay. So we remarked above that the relation of inclusion between classes is insufficient. This results from the irreducible nature of relational propositions. Take example, Socrates is married implies Socrates had a father. Here it is. By the way, this paragraph is a bit confusing. I'm probably not going to say much about this. Here it is affirmed that because Socrates has one relation, he must have the other. Let me change the page, by the way. Or better still, take A is before B implies B is after A. This is a formal implication in which the assertions are, superficially at least, concerning different subjects. The only way to avoid this is to say that both propositions have both A and B as subjects, which, by the way, is quite different from saying that they have the one subject A and B. So this is kind of making a reference to what's coming up in chapter 5 with A and B. So this word "and" here is being used in a very particular way to express a very specific kind of combination between these two terms A and B, such that A and B it's not one term, A and B. It's not the collection A and B, but it's also not quite many. So remember, if you've watched the videos that I've done on chapters 5 and chapter 6, then a class. So what he's getting at here is A and B form a kind of class, I guess. A class can be viewed as one, can be viewed as many. This conjunction, it kind of represents a limit between one and many. So if we combine terms using this "and" word, they have enough unity to not be many, but they don't have enough unity to be considered one. So it's somewhere in between many and one. Okay, so in other words, A and B, we don't have two subjects here. So A and B are subjects, so we don't have one subject. Do you know what? I'm not going to say any more about it because I'm tying myself in knots with it. Such instances make it plain that the notion of a propositional function and the notion of an assertion are more fundamental than the notion of class, and that the latter is not adequate to explain all cases of formal implication. I shall not enlarge upon this point now, as it will be abundantly illustrated in subsequent portions of the present work. It is important to realize that, according to the above analysis of formal implication, the notion of every term is indefinable and ultimate. A formal implication is one which holds of every term, and therefore every cannot be explained by means of formal implication. By the way, every term, this is very important. This concept, every term, is very important when it comes to the variable. So chapter 8, the variable. Where is it? So section 88, we may distinguish what may be called the true or formal variable from the restrictive variable. Any term is a concept denoting the true variable. Not every term. No, that's right. Okay, no, it's a slightly different thing. Every cannot be explained by means of formal implication. If A and B are B classes, we can explain every A is a B by means of X is an A implies X is a B. But the every which occurs here is a derivative and subsequent notion, presupposing the notion of every term. It seems to be the very essence of what may be called a formal truth and a formal reasoning generally, that some assertion is affirmed to hold of every term. And unless the notion of every term is admitted, formal truths are impossible. So we understand this concept, every term, as indefinable. So section 45, the fundamental importance of formal implication is brought out by the consideration that is involved in all the rules of inference. This shows that we cannot hope wholly to define it in terms of material implication, but that some further element or elements must be involved. So that's what he's getting at in section 44 with this relation between the assertions. We may observe, however, that in a particular inference, the rule according to which the inference proceeds is not required as a premise. So I think this is what he was talking about in section 38. When he's talking about the Lewis Carroll's puzzle, what the tortoise said to Achilles, where certain so he's talking about if we've got P implies Q and P asserted, then we can assert Q. Okay, but there's no symbolic formal reduction of this principle. It just has to be observed that we have this this instance of this rule occurring. So P implies Q and is asserted, and P is asserted. We have an instance of a particular rule that cannot be expressed formally, and therefore we can express Q. I think this is what he's getting at in what he's about to say. So this point has been emphasized by Mr. Bradley. I'm not familiar with Mr. Bradley's work. It's closely connected with the principle of dropping a true premise, which is what I've just been talking about there. Being again a respect in which formalism breaks down. In order to apply a rule of inference, it is formally necessary to have a premise asserting that the present case is an instance of the rule. We shall then need to affirm the rule, by which we can go from the rule to an instance, and also to affirm that here we have an instance of this rule, and so on, into an endless process. The fact is, of course, that any implication warranted by a rule of inference does not actually hold, and is not merely implied by the rule. Okay, so whatever rule we're using here, when we've got P implies Q asserted and P asserted, then we can assert Q. This is not implied by any rule as such. This is simply an instance of the non-formal principle of dropping a true premise. If our rule implies a certain implication, the rule may be dropped and the implication asserted, but it remains the case that the fact that our rule does not imply the said implication, if introduced at all, must be simply perceived. We just have to observe that we have an instance of this rule. Okay, it's not implied by the rule. So what's going on here is not implied by the rule. It's just this is an instance of the rule, and we have to perceive that it's an instance of the rule and use the rule. And is not guaranteed by any formal deduction. And often it is just as easy and consequently just as legitimate to perceive immediately the implication in question as to perceive that it is implied by one or more of the rules of inference. It's a little bit, I don't fully understand what he's saying necessarily, but what I've said is the way that I understand it. To sum up our discussion of formal implication, a formal implication, we said, is the affirmation of every material implication of a certain class. And the class of material implications involved is, in simple cases, the class of all propositions in which a given fixed assertion made concerning a certain subject or subjects is affirmed to imply another given fixed assertion concerning the same subject or subjects. Where a formal implication holds, we agree to regard it, wherever possible, as due to some relation between the assertions concerned. That's section 44. This theory raises many formidable logical problems and requires for its defence a thorough analysis of the constituents of propositions. To this task, we must now address ourselves. So that's the end of this chapter. Then naturally it's on to chapter 4, which I've already covered in some previous videos. So I think I've said everything that I need to say about this chapter. There are a lot of things that I find are very unclear in principles of mathematics. As I've said in previous videos, please don't take these videos as definitive, that I'm trying to suggest that I have the answers to all of the questions. I'm just trying to give my interpretation of principles of mathematics. So if you do have any questions, please feel free to ask. Please let me know how you'd like me to continue with principles of mathematics, or whether you've had enough of it. But I'm going to leave it there with this video, and I will look forward to seeing you in the next video.